What is CHIPS?
CHIPS is a CNC12 add-on that integrates multiple functions into one user-friendly app. CHIPS replaces the CNC12 tool library with an integrated tool library manager with enhanced functionality. CHIPS eliminates the complexity of tool offset probing with a one-button push. CHIPS provides automated tool offset measuring cycles before and during a job run. The Precision Touch Probe calibration feature measures individual pre-travel distances for all 4 X and Y axis directions to increase probing accuracy. The Touch Probe Trip Map utility will give a clear picture of what precision can be expected from a touch probe and will visualize the probing errors in all X and Y axis directions. An enhanced MDI allows to interactively create command files. A single button press on the virtual or physical control panel does open CHIPS and does provide easy access to all these features. Now let's have a look at CHIPS and how it integrates with CNC12. The CHIPS installation provides the functionality to place the CHIPS button at any position on the virtual control panel. On machines with a physical control panel, any auxiliary button can be used to launch CHIPS. CHIPS is using the Centroid API to communicate directly with CNC12. A message in the CNC12 message window will confirm that CHIPS has successfully connected to CNC12. The tool data in the CHIPS tool library is retrieved from CNC12 and all changes are immediately synchronized. As an example, correcting the diameter offset of tool number 1 here will instantly synchronize the change with the CNC12 tool offset library. Unlike CNC12 where the tool and the offset library are 2 separate libraries, CHIPS presents all tool data in one table. Also, if a diameter or height offset number doesn't match the tool number, the operator will be warned by highlighting the non-matching data. The CHIPS tool library contains extended tool data that's not part of the CNC12 tool library. The additional data is managed by CHIPS internally and can be used to improve tool change messages to the operator. The tool library services can be reached with the button on top of the tool library table. Here you can back up the whole tool library data including the CHIPS extended data or erase all tool data if needed. In the import drop-down list, you can select to restore a backed-up tool library or import tool data that was exported from a CAM system. When backing up the tool library, you can accept the proposed name with the current date and time, or you can specify your own name in case you are keeping dedicated tool plates for each job. If the need arises, the complete tool data including the CHIPS extended data can be erased. As can be seen, all tool data has been erased. Now let's import tool data from Fusion 360. Here we select the Titan building block library that was exported from Fusion 360. The CHIPS importer analyzes the data and displays warnings. Here it found that tool number 10 is configured in CNC12 as the touch probe that doesn't match with the import data. The tool table is now filled with the Titan tool data from Fusion 360. Now let's restore the tool library that we have backed up before. As can be seen, tool number 4 has been identified as having mismatched diameter and height offset numbers. Pressing the import button will replace the Titan tool data with our backup data. Another useful feature is the tool table filter. It allows to display only the tools that fulfill a certain criteria. Here we select to show only the tools that are needed within the currently loaded job file. Measuring tool height offsets is as easy as selecting one or multiple tools on the tool table and press the Probe Selected Tools button. Note that this feature can differ based on the machine configuration as explained in the configuration chapter later in this video. This section is dynamically built based on the configured probing devices and will give direct access to the probing cycles of each device. As an example, pressing the Avid CNC device button will open the probing cycle screen of the device. The left side of the CHIPS window does give direct access to all touch probe probing cycles. In addition to the CNC12 internal touch probe cycles, CHIPS provides 2 triple-axis cycles to set the world coordinates at the center or any of the 4 corners of a rectangular stock. Also, the bore cycle has an option to find the center with only 3 probing points. The probing cycle have enhancements over the stock CNC12 cycles by adding the options to reset any axis separately, set an offset, and select any of the available world coordinate numbers to be reset. Also, the cycles provide the option for precision probing for more accurate probing results. The button with the gear icon on the top left does give access to utilities and default configuration settings like the standard touch probe calibration. The precision touch probe calibration. The touch probe trip map utility. And the CHIPS default settings. The MDI button, short for manual data input, allows to direct or interactively send commands to CNC12 for execution. This can even be done while CHIPS has been opened through an M6 tool change command from a running job and is currently on an M200 wait loop. In the command entry window, you can enter commands directly and run them. On the right side is the command picker section where you can select from G codes, M codes, and probing commands. A command can be picked from the list and a template of the command can be added to the command entry window. The command usage window in the center does provide information about the expected parameters of the command. This way, a customized probing macro can be created quickly and interactively. Here's an example of a macro that probes 3 bore holes and records the size and positions of the holes into a log file. How easy is it to install CHIPS? Just download the CHIPS installer package from the provided link and run it on the CNC12 PC. After all files have been copied to the CNC12 PC, the CHIPS button configurator will open. The button configurator will read the currently active layout of the virtual control panel. If the machine has only a physical control panel, an auxiliary button can be selected. On the virtual control panel layout, select the position at which the CHIPS button should be placed. Now restart CNC12 as instructed if it's open. The CHIPS button will now appear on the selected position of the virtual control panel. How easy is it to configure CHIPS? Well, judge for yourself. Centroid's CNC12 is an excellent CNC control software package that supports an enormous variety of different machine configurations. This also creates some challenges as it can be overwhelming to configure it correctly, especially when it comes to selecting and configuring the appropriate way to measure tool offsets. CHIPS takes away a lot of the complexity and makes the process a lot easier. When CHIPS starts up for the first time, the operation mode selection screen will be presented. CHIPS supports 3 different operation modes. The appropriate mode needs to be selected based on the machine's capabilities. This is the first important step to get the configuration in the right direction. Now let's have a quick look at the 3 operation modes, and we start with Operation Mode 1. Operation Mode 1 is targeted for professional machines that have a tool setter or laser device that can measure tool height and diameter offsets. Also, a spindle probe and a calibration tool is needed. The machine must have fixed tool holding and the spindle must be fully controlled by CNC12. When an operation mode opens for the first time, the configuration page will open and configuration parameters need to be saved. Touching a parameter will pop up information about the parameter. The parameters for a laser device are slightly different from a tool setter. After the configuration has been saved, the chip's main screen for Operation Mode 1 will be displayed. As can be seen, the Tool Library Manager for Operation Mode 1 looks slightly different from Operation Mode 2 that was shown in the intro part. Operation Mode 1 is the only mode that supports rotational tool probing profiles that include tool diameter offset probing. CHIPS has many checks to make sure all needed data is available. In this example, if we select tool number 1 for probing and press the probe button, we get a warning that the tool setter has not been calibrated yet, as can be seen in the calibration section. Calibrating the tool setter is as easy as pressing the tool setter calibration button, and CHIPS will guide through the calibration process. After the calibration cycle has finished, the time and date of the calibration will be displayed. Operation Mode 2 is for all machines with fixed tool holding that don't need rotational tool probing cycles. This operation mode supports a wide variety and combinations of probing devices from spindle probes to fixed and movable tool touch-off plates, as well as 3 types of triple edge finder plates, including the very popular Avid CNC plate. Configuration is as easy as selecting the probing devices that are available on the machine. The configuration page will dynamically present configuration parameters based on the selected probing devices and the selected tool height offset method. When the configuration is saved, the settings will be verified and checked for completeness. The configuration won't save until all required settings are given. The probing buttons on the bottom are dynamically generated based on the configuration settings. As an example, if it's preferred to use the Avid CNC plate to set Z0 rather than the movable tool setter, this can easily be changed in the configuration settings as shown here. Operation Mode 3 is for all machines that don't have fixed tool holding and tool height offsets need to be measured after each tool change. This operation mode supports the single probe as well as the dual probe method. The configuration of Operation Mode 3 is as easy as selecting the available probing devices and the desired tool height offset method, and the configuration screen will be dynamically generated with the required parameters. As can be seen, there's a great variety of tool height offset methods available. All that needs to be done is selecting the desired method and CHIPS will do the rest. In this example, we select the most common dual probe method with a movable and fixed tool touch of plate. After entering and saving the required parameters, CHIPS will give a warning that all tool height offsets will be reset to 0 to avoid any issues when running a job file that will enable tool height offsets. On the right side of the Tool Library Manager screen, CHIPS has dynamically generated the probing buttons and instructions based on the selected tool height offset method. This concludes the introduction of CHIPS. For more detailed information, please consult the CHIPS user guide.